Hello everyone, welcome back. I'm Boomy and today we are watching The Great Silence by Lemmino. Yes, this one is probably going to talk about the Fermi paradox, most likely, how the universe is so big yet we've managed to find zero signs of other intelligent life out there. It's not just that, the silence part probably refers to how we are not seeing any form of communication that we managed to intercept, at least that we know of. As you probably may know, I love everything about space. Space related videos are my jam, so I'm excited to watch this one. So let's go ahead and check this out. And remember, if you like my reactions, don't forget to leave a like, let me know your thoughts on the video down in the comment section below, and consider subscribing. Also, don't forget to leave your suggestions on what I should check out next. That being said, let's go ahead and watch the video.
Just let me know.
Sounds familiar.
In
Is this the WoW
1967,
signal?
a postgraduate student at Cambridge University by the name of Jocelyn Burnell was surveying the sky with a newly constructed radio telescope. After a few weeks, she discovered something odd. The telescope had picked up a radio signal that seemed to be pulsating. The pulses had an interval of exactly 1.33 seconds and were initially thought to be nothing more than man-made interference. However, it soon became clear the signal did in fact emanate from deep space, and the unwavering precision of the pulses was unlike anything seen before. As such, many questioned whether it was a naturally occurring phenomenon or a transmission from another civilization. The radio source was even named LGM-1, an acronym for Little Green Men,
Oh,
and
okay.
Burnell herself could not help but wonder if
Well,
she'd
this isn't
actually
a WoW
discovered
signal.
the first sign of life beyond the Earth. As you might expect, it didn't take long for natural explanations to emerge, and we now know these pulsating signals to be produced by rapidly
Pulsars.
rotating neutron stars, known as pulsars, that emit beams of radiation akin to the beams of light emitted by a lighthouse. If nothing else, it made for a neat album cover. Ever since, an international effort known as the Search for Extraterrestrial Intelligence
SETI.
has actively been listening for artificial transmissions, but so far we appear to be the only ones broadcasting into the void. Humanity has been leaking radio signals into space for the better part of a century, so any eavesdropping aliens within about 100 light-years could potentially be alerted to our presence. Beyond this invisible radio bubble enveloping some 15,000 stars, the Earth is just another silent speck. Not only that, but as technology improves, this radio leakage is dramatically reduced. Before long, Earth may return to a state of radio silence.
Yep.
If most civilizations improve and eventually outgrow radio technology at a similar pace, the radio signature of any one civilization may only be detectable for a very brief period of time. Furthermore, this radio leakage is extremely faint and only grows more and more diffused as it expands into the galaxy. Some of the most powerful signals to leak into space are military radar emissions, and stand a much better chance of detection across interstellar distances than the average television broadcast.
Now, the problem with that is if they manage to interpret that, then some of the strongest signals that come from Earth are military signals. So that would mean that they will probably think that we are like a very militaristic planet. And that's probably one of the reasons why no one has contacted us yet, because they probably don't know what our intentions were, and rightly so.
The Square Kilometre Array, a vast interferometer to be constructed in South Africa and Australia, could be sensitive enough to detect a faint radio signature of an Earth-like civilization out to a distance of several hundred light-years. To detect more distant signals would require more deliberate attempts at communication. For instance, an advanced civilization may construct powerful beacons specifically to increase their radio luminosity. These beacons would be rather expensive to maintain, as they would consume vast amounts of energy for extended periods of time. A less expensive alternative would be a focused beam of radiation as opposed to an omnidirectional broadcast. In 1974, the Arecibo Observatory in Puerto Rico
no.
famously beamed an interstellar message
This has been
towards
taken
globular
down.
clusters some 25,000 light-years distant. The message took less than 3 minutes to transmit, so any prospecting aliens in the path of that signal would have less than 3 minutes to detect it, and they will never get a second chance. We may have been on the receiving end of such an interstellar message when in
The WoW
1977,
signal.
a momentary burst of energy swept across the planet. Repeated attempts at redetection notwithstanding, the famous WOW signal was never detected again, and its origin has never been conclusively ascertained. On the slim chance that it was of artificial origin, a reply was beamed in a general direction whence it came in 2012. In a galaxy as old and vast as the Milky Way, the probability of two civilizations stumbling upon one another by briefly screaming in random directions is not great. To increase our chances, we need to limit our selection of targets by searching for other technological and biological signatures. In 1995, the first extrasolar planet orbiting a sun-like star was discovered. We now know that the vast majority of the hundreds of billions of stars in the Milky Way galaxy are home to at least one planet. We also know that billions of those planets are of similar size to the Earth and orbit within the habitable zone of a star similar to the Sun. This means that liquid water could exist on the surface, which is an essential ingredient for life as we know it. Furthermore, billions of extrasolar moons may also be capable of supporting life. With this knowledge in mind, in 2017 a message was beamed towards one of the least distant and most Earth-like exoplanets discovered to date. The message comprised a number of musical compositions and basic information about humankind, and should the planet be inhabited, we could expect a reply as early as 2044. Here's a quick preview of that future. However, habitability, a quick preview of that future.
Breaking news, humanity ghosted by nearby exoplanet. Oh man.
However,
I don't know if that's a
habitability is
good
no
thing or a
guarantee of
bad thing.
habitation. To determine whether a potentially life-supporting planet is currently supporting life would require a more careful examination. For instance, by analyzing the starlight passing through the atmosphere of an exoplanet, it is possible to deduce its chemical composition. The spectrum of an oxygen-rich atmosphere will differ from that of, say, a hydrogen-rich atmosphere. Given that photosynthetic plants and organisms are responsible for the large quantities of oxygen on Earth, an exoplanetary atmosphere with a similar concentration of oxygen could be taken
Oh,
as a
that's a
sign
big
of
storm
life.
right there.
This is known as a biosignature, but it's far from definitive, as oxygen could also be the result of various abiogenic processes. As such, astrobiologists are more interested in certain chemical combinations, as it would be far less likely for, say, methane and carbon dioxide to coexist in the absence of life. Speaking of carbon dioxide, some chemicals can be indicative of industrial pollution, and thus artificially induced climate change could serve as the universal sign of unintelligent life. In addition to biosignatures, we may be able to detect signs of technology. For instance, an exoplanet surrounded by a dense orbital belt of artificial satellites or space debris could be detected during transit of its parent star. This would be an example of a technosignature. A more extreme example would be a megastructure.
Yep. But how would we be able to determine if that is just an artificial satellite or an actual satellite? By that I mean like small asteroids that just so happen to orbit around a planet. It doesn't have to necessarily form like rings, the same as Saturn has, but it could be something like what we saw just a few seconds ago, where it's all scattered around, making it look like artificial satellites. Unless we get a more powerful telescope. Was it the James Webb that just came up a few months ago? That could help us out.
The initial speculation surrounding the discovery of pulsars has become somewhat of a recurring theme. Whenever an astronomical discovery initially defies explanation, vigorous speculation about aliens takes center stage. In more recent years, this discussion has been dominated by a peculiar star some 1500 light-years distant. the star exhibits erratic light fluctuations and occasionally dim by as much as 22%, and so one hypothesis is that an alien megastructure is blocking the light from the star. While evidence of astroengineering is still within the realm of possibility, the dimming is now thought to be caused by nothing more than dust. The existence of circumstellar
large dust
megastructures
clouds.
was popularized by theoretical physicist
Freeman
Freeman Dyson back in
Dyson.
1960 as a potential means for advanced civilizations to harness the energy of their parent star, commonly known as the Dyson sphere or Dyson swarm. According to the Kardashev...
By the way, these two are like my favorite like sci-fi concepts, just because it gives so much power, which will enable a lot of things.
Scale, a method of measuring a civilization's energy consumption proposed by astrophysicist Nikolai Kardashev in 1964. A Dyson sphere would be indicative of a Type 2 civilization. A Type 1 civilization could harness the energy of its home planet. A Type 2 civilization could harness the energy of its parent star. A Type 3 civilization could harness the total energy output of an entire galaxy. Extensive surveys of billions of stars notwithstanding, there is no reliable evidence of a Type 2 nor Type 3 civilization in the Milky Way galaxy. So far. What about extragalactic life? After surveying 100,000 nearby galaxies for signs of a Type 3 super
Those look
civilization,
so beautiful.
Astronomers found no signs of a galactic empire.
I mean, if you think about it, we found no signs using the technology that we currently have now. If we get more powerful telescopes, maybe we can like get clearer images and more detailed analysis from each star.
The great silence of the universe can be a bit unnerving. Humanity is now on the verge of detecting biosignatures on extrasolar planets, but Earth has been radiating detectable biosignatures for billions of years. Yet, as far as we can tell, it's failed to attract the attention of any alien astronomers. The apparent contradiction between the expectation and lack of evidence for extraterrestrial life is known as the Fermi paradox.
Yep.
Given the sheer size and age of the universe, why does it appear to be so lifeless? It is possible to concoct a myriad of hypothetical solutions.
Let's see here. Let's back it up a bit. No.
Lifeless. It is possible to concoct a myriad of hypothetical solutions.
Alright, we got a rare Earth hypothesis. This basically means that the situation that we have here on our planet is incredibly rare, that it's not replicated elsewhere. We got the Great Filter. Yeah, it's already there. Universal barriers. That could be like nuclear war, gamma ray bursts, isolation. Aliens favor isolation. Yeah, I could see that. I mean, the only reason why we think that aliens would be conquering everything is because we ourselves as a species have that conquering mentality, but it doesn't necessarily have to be true to other aliens. Planetarium, yeah, basically the simulation hypothesis. Transcension, I don't know what they mean about transcension. The zoo hypothesis is actually really funny though, that aside from deliberately evading detection, it also indicates that they might be like watching us, studying us, instead of actually interacting with us.
Perhaps life is common, while intelligent life is exceedingly rare. After all, it took some 4 billion years of evolution and a number of mass extinctions before humans emerged on Earth. Proponents of the rare Earth hypothesis suggest that complex life on Earth is the result of an improbable chain of events, unlikely to occur more than once. Perhaps there exists a barrier, either improbable or impossible for life to overcome. If the barrier is behind us, we may be among the fortunate few to have crossed it. Potential candidates include the emergence of multicellular organisms and the invention of nuclear weapons. If the barrier is still to come, we may soon join the cosmological graveyard of fallen civilizations. Potential candidates include
Global
unsustainable
warming,
climate change and the invention of nuclear weapons. Perhaps we severely
dual-edged sword.
underestimate how truly alien aliens can be. All life on Earth is carbon-based and rely on water, but life could hypothetically be silicon-based and thrive in oceans of liquid ammonia. Just as we search for life as we know it, aliens may be doing the same. Perhaps an advanced civilization did in fact pay us a visit in the distant past. Unless some sort of evidence of that visitation survived for millions or billions of years, we'd never know. Even a visitation in the recent past could have been misconstrued as gods descending from the heavens. Well, I mean, that would have been a fairly accurate interpretation.
It would be funny though to think that Jesus was actually real, but he was an alien.
Perhaps all civilizations inevitably develop technology that transcend physical reality. For instance, reality could be rendered obsolete by hyper-realistic simulations. By transferring one's consciousness into these virtual wonderlands, one could achieve digital immortality. The happenstance offerings of nature would struggle to compete with the promise of utopia. Throughout the galaxy, pockets of advanced civilizations may occupy no more than a few star systems as they explore inner space in place of outer space. In his transcension hypothesis, futurist John Smart takes it a step further and supposes this introverted evolution will progressively miniaturize computers until they are so intensely compressed that they generate an environment analogous to black holes. These post-biological civilizations would thus transcend the space-time continuum and vanish from the visible universe. Hypothetically speaking. Apart from artificial transmissions and distant signs of astroengineering, there's also a far less remote form of technosignature. The Voyager spacecraft was launched in 1977, and as of the making of this video, it is the only probe to have reached interstellar space. It famously carries a golden record with information about mankind, but it will take another 40,000 years before the probe encounters another star. In an effort to more expeditiously explore the galaxy, an advanced civilization may launch sophisticated interstellar probes capable of self-replication. These probes would be intelligent enough to mine the available resources in any given planetary system to create copies of themselves. These copies would then travel to neighboring systems and create additional copies. If these probes could travel at just 10% the speed of light, a speed attainable by modern methods of propulsion, every corner of the galaxy could be exhaustively explored in just a few million years. A relatively short amount of time on cosmological timescales. Mankind is now fast approaching the technological sophistication to launch such a probe. This begs the question, why is the solar system so probeless? If human progress is any indication, the galaxy should be completely overrun by self-replicating automata, yet we see no evidence of that. An ongoing hunt for alien artifacts has yet to locate any covert probes lurking in the solar system, but space is vast. An object of extrasolar origin could easily be zipping around our cosmic backyard without our knowledge. In fact, that is exactly what happened in 2017. An extrasolar object named Oumuamua passed through the inner solar system and went completely unnoticed until it was moving away from the sun. Even then, its discovery was pure luck, and thousands of extrasolar visitors could go undetected each year.
That's the problem with like trying to detect probes. It's basically how is the best? Probably like if you imagine a probe as big as a house, you'd think that that would be really big and very, very noticeable. But in the vastness and darkness of space, that is really nothing. I mean, it would probably take something like the size of the moon to be easily detectable. But yeah, small probes, I don't think we have that capability. Unless if we see like how do you call this? I don't know if we have one or not, but imagine No Man's Sky. This is the first thing that comes to mind, right? Imagine No Man's Sky has the scanner where it's basically a sonar, and I don't think we have that, right? To detect like objects in space, even if it's just near Earth objects. Because if we have that technology, then I'm not sure. I haven't heard of it, but yeah, we could probably use something like that to detect all nearby like objects.
Size and shape of Oumuamua can only be inferred by the amount of light it reflects, but it appears to be highly elongated or extremely flat. Initially, it was thought to be a comet, but the absence of a cometary coma, a trailing cloud of dust and gas typically formed when comets approached the sun, lent credence to it being an asteroid. But then the object began to accelerate. This acceleration would be consistent with the outgassing of a comet, but as mentioned, Oumuamua does not display the expected characteristics of a comet. One possibility is that this outgassing is simply too
Alien.
faint for us to detect, but there is that remote possibility of it being an interstellar probe. More specifically, a probe using a light sail as a means of propulsion. On the other hand, Oumuamua is perfectly radio silent. Perhaps it's a defunct probe, destined to aimlessly roam the galaxy.
Just like Voyager.
Much like Voyager.
Yeah.
It's important to remember that with a sample size of 1, that being Earth, we cannot possibly know how common or rare life truly is. There could be hundreds of planets or millions of galaxies between us and them. If life was discovered elsewhere in the solar system, perhaps beneath the frozen mantle of Europa, we'd be able to compare and contrast 2 distinct sources of life and gain crucial insight into its commonality or rarity. Many reject the anthropocentric view of Earth as a cosmological oddity due to the sheer number of Earth-like planets coupled with the resilience of life on Earth. But the truth is, we don't know. We don't know if billions of planets is sufficient for intelligence to arise more than once. We don't know the prerequisites for abiogenesis, the transition from non-life to life. We don't know the probability of cosmic solitude. But to conclude that we are alone in the face of all this ignorance is more than a bit presumptuous. The extent of our search for extraterrestrial intelligence has been compared to searching a glass of water for evidence of fish in all of Earth's oceans. Space is unimaginably vast, and we have barely begun to scratch the surface. There are so many untapped avenues for detecting signs of life that if we just turned that telescope a bit to the left, made it a bit larger, and listened to a slightly different range of frequencies, perhaps the universe wouldn't be so silent.
Yeah, that's true. Because if you're looking for direct signals, depending on how far they are, the slightest bit of angle change can lead to like a great distance away from our satellite's targeting system. So it has to be incredibly precise if we're looking to catch one of those directed beams at us. And it's done. It's done, yeah? Yeah. What a great video. What a great video. Space, man. Always intrigues me. I mean, like I said in my past videos, if they ever come knocking asking for volunteers to go to Mars, even if it's just a one-way trip, I'm gonna have to say goodbye to the channel. I mean, I don't know if I can even make reaction videos on Mars, but yeah, I will definitely sign up. If it were only that easy to become an astronaut, or it doesn't even have to be an astronaut, just go to space, I would sign up. Let's see, if SpaceX gets the cost of space travel so low, it doesn't have to be incredibly affordable to everyone, as long as it's very reasonably priced and affordable, I would spend my life savings on it. That will be an experience that I am not gonna miss out. But until then, we're just gonna have to wait. So that's gonna be it for me today, guys. Link to my Twitter is down in the description below. Go and check it out if you want to. And if you're new here and enjoyed the video, don't forget to leave a like. Let me know your thoughts on the video down in the comment section below and consider subscribing. Also, don't forget to leave your suggestions and what I should check out next. That being said, thank you so much for watching and I'll see you all next time. Bye!